All right, so here are just a few examples of composition of functions. So like it says in the Canvas module, composition of functions follows the basic rules of function notation. So we'll just do a few examples together, and if you have any problem with the homework, please let me know. This right here is read f composed with g of x. And this is the same thing, f of g of x. So over here, f of g of x. So we can read this little circle as composed, and we can read these parentheses. Every time we see them, we can say the word of. So f of g of x, or this guy over here, f composed with g of x. So the g function is inside of the f function. So kind of my basic rule here for if we're about to tackle example 1, I'm given two functions here, f of x and g of x, and it's asking me to find f composed with g of 2. So my rule that I sort of, or my little trick that I think of is since 2 is closest to this g function here, I'm going to start by plugging in 2 into my g function. So my first step will be to figure out what g of 2 is. So g of 2 is 4 minus 7, so I end up getting that g of 2 is negative 3. I'm now going to take this negative 3 and I'm going to plug it into my f function. So negative 4 times negative 3 plus 9. So f of negative 3 is positive 12 plus 9. So f of negative 3 is going to be 12 plus 9, which will give me 21. So let's come back over here. We don't want a g. So f composed with g of x, not of x here. Whoop. F composed with g of 2 is actually going to be 21, or f of g of 2 is equal to 21. And you can kind of see this a little bit here. Really what I'm doing is I'm taking g of 2, I'm evaluating that this ended up being, so we can really get a nice sort of visual here, this ended up being negative 3, and then I went ahead and plugged that into my f function. So we'll either do this with values like we just did in this example, starting with f composed with g of 2, or if you look at example 2, we can do it with the actual functions themselves. So this is saying take x, plug it into f, and that output, we want to plug that into g. So g composed with f of x, which I know is the same thing as g of f of x. This is really saying take f of x, which is negative 4x plus 9, and plug it into g. So we'll start by plugging in x into f, so negative 4x plus 9. And we'll take this and we'll plug it into g. So here I have 2 times negative 4x plus 9 minus 7. So this, if I go ahead and distribute, will give me negative 8x plus 18 minus 7. So the composition of these two functions here is negative 8x plus 11. That would be my final answer. So coming on down here, let's do problem number 1 together. So we have f of x is equal to x squared minus 4x plus 2. G of x is 3x minus 7. So I'm looking for f of g of x. So again, I'm taking g of x and I'm plugging it into my f function. So g of x is 3x minus 7. I can't simplify that any further. So f of 3x minus 7, I think if we switch colors here, it will give you a really nice visual. This will become 3x minus 7, and we'll come over here to a nice pink color, squared minus 4, we'll go back to our red because that's part of my f function, or sorry, my g function, 3x minus 7, and back to my pink function, which will give me plus 2. So here I have 3x minus 7 times 3x minus 7 minus 4, 3x minus 7 plus 2. And we can go ahead and simplify this out. This is going to give me 9x squared minus 21x. So also minus 21x plus 49 minus 12x plus 28 plus 2. So if we keep going here, 9x squared, this will give me minus 42x plus 40, I wrote that backwards, plus 49 minus 12x plus 30, and I have two pieces of like terms to go ahead and combine. So 9x squared minus 42, or so negative 42 plus negative 12x is going to give me negative 54x plus, and 49 plus 30 will give me 79. So this is my final answer for problem number 1, where we were talking about f composed with g of x.